Hi, today I want to talk about the Claisen and Cope rearrangement. So, an easy way to go about solving these problems is locating the oxygen and where the double bonds are relative to that oxygen. So, as you can see here, I've labeled the structure 1, 2, 3, 4, and oxygen is on carbon 4, or position 4, and we have 5 and 6. And so, this is a pattern that you have to recognize. There has to be a double bond on carbon 1 and 2 and a double bond on 5 and 6. And oxygen has to be on position 4. And so you can easily convert this into the Claisen rearrangement by drawing out the benzene ring. So we have carbon 1, 2, 3, and then we have 4 here, and we continue on. 5, 6. 1, 2, 3, 4, 5, 6. And so the double bond would still be on carbon 1 and 2, and there'd be a double bond on 5 and 6. And so now, an easy way to remember this is that the 3 and 4 sigma bond goes to the 4 and 5, while the 6 and 5 double bond is moved over here to close this ring, and that forces this double bond to push down. And so the end result would look like this. Double bond there, and then this bond is broken. So this bond is broken here, and then so the 5 and 6 double bond is moved to 6 and 1, and then 1 and 2, and then 2 and 3 has the double bond here. So this bond right here is newly formed, and this bond right here was lost. And so this trick also works for a normal carbon instead of an oxygen, and that's known as a Cope rearrangement. So if we draw out the same structure, carbon 1, 2, 3, 4, 5, and 6 with 5 and 6 and 1 and 2 with a double bond, you essentially just locate the same carbon or oxygen at the 4 position right here, and you would draw it the same way with carbon 1, 2, 3, 4, 5, and 6. We have 1, 2, 3, 4, 5, and 6, and you just translate it over 1 and 2, 5 and 6, and then the same thing happens. The 3-4 bond breaks, and it goes to the 4-5, and the 6 connects with the 1, and the 1-2 breaks to form a new bond on 2-3, resulting in a similar structure of carbon 1, 2, 3, but 2-3 has a new bond, and then we lost this bond, the 3-4 bond, so then we will start over here with the 4, 5, 6, and then 1 forms a new bond with 6. We have 1, 2, 3, 4, 5, 6. And so the 3-4 bond is now in the 4-5 position. And so that is how you do a Claisen and Cope rearrangement. Claisen is essentially just saying there's an oxygen at the 4 position, and Cope is just a carbon on the 4 position. And a side note is that even if there's a benzene ring, you can still do either one of the rearrangements. So you just have to label 1, 2, and then if there's a 3, 4, 5, 6. 4, 5, 6. So as long as there's a double bond at the 1, 2, and 5, 6 position, and oxygen's on the 4 position, you can still rearrange it. And so the resulting product would look something like this. So you have the 1, 2 bond going on to the 2, 3, and the 3, 4 bond going on to 4, 5, and the 6 forms a new bond with 1. So the result is a benzene ring. Oops, let me get rid of that real quick. Just erase that. And then it's benzene ring. 1, 2, 3. And so we'll still label it 1, 2, and then we have 3. And now the 2, 3 has a new double bond right here. And then so remember, the 6 forms a new bond with 1. So we have a 6 bond here. So this is 6. And then it goes to 5, carbon 5. And then oxygen is on the 4 position. But remember, this bond from 3 to 4 changed to this bond right here. So 3, 4 went to 5. And so we have this double bond right here. And so that is the resulting rearrangement of Claisen rearrangement.